Hello and welcome to my tutorial. I'm going to show you how to create a tree in 2D Tilezone, and then I'm going to show you how to set up a procedurally generated world and put your tree into that procedurally generated world. Then after that, if we've got time, I'll show you how to procedurally generate a tree even. So let's get started. I've got a basic scene with a directional light, and we've got a tileset texture that I want to use, so we need to create a material for that, which I'll just use standard specular setup. Put in a tile set, and we need it to be cut out for the transparency to work properly. Yeah, that looks alright. So open up our Tileset Editor, drag in our material, and tile size looks fine. Yeah. Okay, so first we need to set up our auto tiles. Well, first we need to create a new layer actually, which we'll do 7 by 16 for our tree. And now we can set up our auto tiles. So we'll start off with a ground. Look at that. Grass. And then we're going to want a tree trunk. Okay. So place the middle, actually individual can just be a little top bit, and then we'll have to describe how it's going to link to other layers, which is exactly the same as how it'll link to itself, but we just won't have two trunks next to each other. So we need to do that all the way up and there as well. And that is our basic tree trunk, which looks alright. And that's how it'll link up to something beside it, which won't be a tree trunk. We'll create a branch and have that linked together. So we'll just quickly set up this. And we won't see the branch individually, but it's necessary to fill in at least these 4x4 tiles, otherwise your auto tile won't work at all. So now place our branch. It doesn't look interesting yet, but we need to link it to the tree trunk, and we need to link the tree trunk to the branch. Link with branch. Now everything's looking good, so we can create a leaves layer. I'll just quickly set this up. So now we've got our leaves. Now we want the tree trunk to connect to the leaves, and we want the tree branches to connect to the leaves, but we don't want the leaves to connect to anything else. I'll show you what I mean. So tree trunk, link with leaves, tree branch, link with leaves, and then drawing with the leaves. That connects up nicely there, connects up there. Yep, that's looking brilliant. We've got ourselves a simple tree, which I'll save data asset and call it tree data. And now we can set up our world, where we can set up a procedurally generated world, and we want to be able to stamp this tree here into our procedurally generated world. I won't get too in depth into it, I'll just do a basic world, and you can get creative yourself. So we'll need a new layer, 16 by 16, that's good enough, and we'll copy the auto tile data and paste it. It's important that they've got the same auto tile data, otherwise the tiles won't work when you paste them. So we don't need this tree anymore. Delete that, we've got it there. We can test that by selecting Tileset Editor and stamping it, and yep, works perfect. Undo that. So to create a procedurally generated world, we need to create a new C# script, and it needs to derive from scriptable tile layer base. So call it world generator. Let's do this. So it needs to derive from scriptable tile layer base. We don't need start and update. And we'll save this for now, I'll just show you. Where are we? If we drag in that onto layer 2, automatically we've got a lot of control over chunks, so we can change, we'll say we'll make it 4 chunks by 2 chunks, apply. And if we've got our auto tile, it automatically links between the chunks, and there's no problems there, it's all sorted for you. So you'll notice there's a clear and generate button here, which does absolutely nothing apart from it'll just clear the data for now. But we can override generate method, and what that'll do is we can write directly to the data stream, and then when we click generate, it'll generate whatever we've written into the data stream. So we don't need the base method, there is no base method. So let's create a simple world. We'll need some public variables. We'll need ground tile. So if we create a tile, it's already got a nice property drawer, which we can select the tile from the Tileset Editor. And we'll also need a tile data asset base, which is for the tree. And we'll also set up some other variables so we can have a bit more control. We'll have a ground height. That needs to be a int. And we're just going to create a simple height map, like a 2-dimensional height map. So we'll use noise for that, which Unity's MathF has a good function for that. We'll use a float noise scale, and that wants to be public. And noise amplitude. Okay, now in the generate method, we're going to need, we can set up what, if you want to use the seed, which is in here, at the moment it's just a number that's there, it does nothing, but it's handy to be able to set up and say random.seed equals seed, and now all your levels, if the early randomness is coming from the random, they will all they should all link up and look the same if the seed is exactly the same. So now we'll make an offset vector to offset equals random dot inside unit circle, say times some number, big number. So we'll use the offset just so we can pretty much pick a position on the noise field to have as our origin, so all the levels are different if the seed's different. And we'll set up a simple loop going through all the x for so width is the total width in tiles of all chunks. So you've got chunk width and you've got width in chunk, and width is both of them together. So we need to get the height, we'll call that h equals, we'll start with ground height, and then add some noise to that. So we'll use Perl and noise, which just returns a value between 0 and 1. So we'll start with the offset, and then we'll add the x times by the noise scale, and then we'll just have the y offset. And we want to multiply that by noise amplitude, so now it'll be a number between 0 and noise amplitude, and that can be our height. So we want to set up a simple loop for the y. Y is less than h. And to set the actual tile data is easy. We just set the data stream dot, and we just index it, which is x, y, and then we need a layer index which starts at 0, and we've only got one layer, it's just 0. You can see the layer index in here, index 0. And if you have other layers, it'll be index 1, index 2, so on. And that we should be able to save this now and generate just the height map without putting any trees in. But we'll need to set up a, oh, what's this? Done something wrong. Oh, forgot to set it equals, of course, ground tile. Guy, yeah. So we would have to set up a few things here, like the ground tile, which, yep, grass. Is it? No, it wasn't selected. Grass. We don't need the tree just yet, but we might as well add that in. Ground height 5. Noise scale, you want this pretty small, maybe 0.1. And the amplitude, which is how high the hills are effectively, so we'll do 5, try that. Clear and generate. Now we've got a simple hills, we can maybe change the scale, make it a bit smaller again even. Try 0. Try half that. And maybe up the amplitude to 10, have some bigger hills. And we can try with a different seed as well. Yes, yeah, that looks fine. Alright. So we'll try and paste in our tree. We'll put in, let's say if x, we want that in the x loop. So we'll want to just say we don't want the trees too close together. So if x mod say 4 equals 0. So every 4 tiles, and we want a random chance, so random dot value is less than say 0.2. So random dot value is just a number between 0 and 1. Yeah. If that, we want to use scriptable tile layer helper dot stamp tile data, and data from is tree, not try, tree. Data to is data stream, and x can be, well, it's the bottom left of the tree, so we want x minus 3 would be the middle of the tree, and y we want h as an integer. And I think if we seal it, it'll put it just on the floor, the one tile above, which should be right. We'll find out. And you've got two options, which is write empty tiles, which means if the tree has tiles that are empty and the area doesn't, it'll overwrite them with empty tiles, and then overwrite, which means if there's a tile already there which isn't empty, doesn't overwrite it, which by default is true. We'll just leave it as that, and we don't need to write empty tiles. And that might work. We'll find out. That should work. Wait for it to clear and generate. Yes, we've got trees. And try change the seed. It's looking pretty good. Yeah. Okay. Now I can show you how you can set up a procedurally generated tree, which will need to create a script which derives from tile data asset base. So procedural tree. So yeah, we should be able to make a tree that we can use as an asset, just like we dragged in this tree. We should be able to drag it straight into here and have it be a procedurally generated tree. So let's start that. Why is that red? I want to derive from, what did I say? Tile data asset base, and implement abstract members should automatically generate a bunch of members which we need. So we need to be able to tell is and bounds. So what we'll do here, we'll just say, just do a basic if x is greater than or equal to 0 and x is less than width, and same for y. Return true, return false. Alright, for get layer hash, it's not actually necessary, but it's handy to be able to test easily just with a single number if the layers are compatible with each other. So make a public int layer hash, which we can set up in the editor if we need to, and return layer hash. Now, is data ready gets called by the stamped data. So if we want the tree to change every single time, we should set up a method to generate and call it from in here. So we'll say generate, which we haven't created yet, and return true, data is ready. And width, we'll do the same width. We had return 7, that's the same as what the tree was. Height, we'll set up some min height and max height. We get a random height between them, and we'll just return the max height for simplicity. And what have we got? Number of layers, well, 1. And so we need some way of storing the data, which we will use. We've got serialized tile data. Serialized tile data, which is just an easy way for storing your tile data and saving it without having to actually generate a level. So data, and we need to create our generate method as well. So get if data doesn't exist, then create it. Generate and then data x, y, 0, x, y, index. Actually no, we'll say 0 because it's never going to be able to be higher than that. Equals, no, we want to return that. And set data xy0 equals value. Alright, now we just need to do our generate method. So if data is null, set up new data. We've got width, height, 1 layer, and we'll just need the layer hash. Well, we don't need it, but need to put something there. Now we need to have tree height. Just have a randomly between min height and max height. And we need to create, we'll just put a trunk in the middle. So now this is just going to be nothing too overly complicated here. You can get more creative yourself, obviously. We'll just put the we need to have the tiles. So we need a trunk tile and branch tile. We won't do leaves for now. We'll leave that to you, sort out. So, what have we got? Data 3 is the middle for the X, and then Y 0 equals trunk tile. And then we'll just have that for now, actually, just to test if everything's working as should be, and then we'll add in some branches. Actually, there's one more thing that we need to do. We say create asset menu. Which should let us, automatically, hopefully it'll automatically let us create a procedural tree. We'll call it new procedural tree. That works for now. So to quickly set up the layer hash, you can just copy this and paste. And then if you want, you can do a check yourself with the layer hash, but it's not necessary. Min height, say 4, max height 10, trunk tile tree trunk, branch tile, tree branch. Hopefully this works. It should just create a branch, a trunk. If I drag the new procedural tree into the tree and generate, it works, but they all seem to be exactly the same height. Why is that? Is that just random? I just need a why is there not that much variation? Min height, max height, tree height. I see, I think is data ready, generate. Do we need to wipe the data? Maybe I'll just set that as a new one every time. Yeah, see if that works. Yeah, now we've got some variation. Yeah, I think it was just taking whatever the highest and the data was still already in there. It wasn't writing empty for everything else. So you could either set new data, which is fine, or you can rewrite the empty ones depending on your setup. So we'll just set up a simple method. We'll call it add branch left, and we'll do the same for right. We'll just do a simple, we'll say data So 2 is just left of the branch. Equals branch tile, and then we'll give it randomly, have it able to be bigger. So if random dot value, we'll just give it 50/50. So data 1 y0 equals branch tile, and then we'll do one more if same again, random and 0 this time. And we'll just copy and paste this for the right. Add branch right, and that'll be 4 just right of the tree. It'll be 5 and 6. Okay, and here we'll say if random dot value is less than, we'll say give it 0.3, add branch left, and we'll do the exact same. Add branch right. Save that. I've broken something again, I'm good at that. Ah, of course, it's a method. Try and generate, and yes, that works exactly how I want it to do. Alright. I'm going to leave it up to you guys. Why is I believe that branch is just not set up correctly in the auto tiles, maybe? Because there's a branch connecting right at the very top. That'll be an easy fix. All you would have to do is tree trunk. Yeah, these top ones here, all you have to do is set them up to have the top. Like so. Oh, but yep, that's working now. We'll just try generate to make sure, clear and generate. Yep, different seed. Yeah, alright, so that concludes our tutorial. Thanks for watching if you've actually managed to stick through this far.